me try to learn some names here.
Che.
Trey. Che. Okay, I messed it up there too. I remember one time. Che. Avalon. Yeah, Avalon. I'll get it eventually. And Zach. Okay, Trey, Avalon, Zach, and this is gonna be the last name I learned today. Zach. Okay, great. So I got Zach and Zach, Avalon and Che. Okay, I'm gonna learn one more. I'm gonna learn in the crime seat back there. Kelly. Okay, so Kelly, Zach, Avalon, Che. Okay, good. It takes me forever. I'm just so stupid. It takes me so long to learn anything. But usually once I've learned it, I can usually pick you out across campus like 3 years from now and be like, oh, okay. Hey, Che, how are you doing? You know, what's going on? Hopefully I won't be asking, or do you have COVID? That's probably hopefully I won't be asking that in 3 years. Hopefully we'll have this problem solved here in a couple of weeks. Hopefully in a couple of weeks, once the election's over, hopefully a good part of the problem will be solved. We'll just have at least all the politicizing of the disease should hopefully go away, so we can just talk about moving ahead. Oh, hopefully some other students will show up here in just a little bit. I'm not quite sure how many are coming to live session. How many are freshmen? How many of you are freshmen? How many people were had to go home and then came back? Anybody? Okay, that had to be fun. To move back in yet again. Move out, move in, move back. I'm so sorry.
It wasn't that bad.
Really? Okay, I'm believing, guys. I'm believing we're gonna own this time. I'm believing that we've got this. Not really, but I'm believing. I'm gonna keep believing. I'm believing we're gonna be in session, guys, until the end. I think we got enough quarantine beds, and I think we got enough testing now and we may be reaching herd immunity. Who knows? I mean, I'm not sure. But it's just so good to have faces back in my classroom. You can see that this is what I would see. You can look behind you there. That's kind of, you guys were back there, and you will be back there again on Wednesday. That's the first I've seen Nick's picture like that, though. I guess that's. Now, if I do this, is that impossible to take notes? If I do that, can you still grab notes from that if I do that?
Yeah.
It just makes it a little easier for me to just see the guys who are on the grid versus people that are in the classroom. All right, I guess we are live. Let's see here. 12 o'clock, that's what I've got, 12 o'clock. We'll see if some. Okay, are you guys, if you got your videos, turn them on. Now I've got like students here and students there. I'm a little afraid to move the camera, but you can see your buddies are in the classroom right here. They're around me right here. You guys are in the grid back there. But I think this is gonna work. Now the nice thing is on Friday, we can all be together as one. On Friday, we can all, my Z days and my A days can all be together. We're in the basement in a big room that can hold, I think, 60 even during quarantine. So I think we're in good shape. And that's gonna make life a lot easier for me. So Z-dayers, you will always be in class on Monday. You'll always be in class on Monday and Friday. And you A-dayers, you guys will be in class on Wednesday and Friday. Does this make sense? Doesn't that make it a little bit simpler than trying to figure out where you're at each week? Even though the university is like, well, you can't have A day and B day. And I'm like, I thought to myself, I don't. I've got A day and Z day, I'm good. And they're like, because the students can't figure it out. And I'm like, these kids went through high school where they likely had block scheduling and had rotating days. I'm pretty sure the kids I'm teaching calculus to can figure out which day they're supposed to be in class. But now it's super simple. A day you're in class, A day you're in class, A day you're in class, Wednesday and Friday, and Z day you're in class Monday and Friday. Okay, good. Okay, just a little review. We're gonna have our second quest win. Friday, down in the room downstairs, it'll be nice, there won't be any WebAssembly, it's just gonna be straight old, here's some paper, here's a paper test you write on. I'll talk more about what's gonna be on the quest, I'll talk more about the content of the quest, but it's basically what we've been going over, it's basically limits and derivatives, say that.
Limits and derivatives.
Tangent line, oh my. Say that. Tangent line, oh my. Okay, let me just see if there's another lecture going on. Maybe I should just shut this. My voice is so annoying. Okay, it is so nice to have human beings back in my, it's so nice having you guys in the grid. Okay, flashcards. Let's see how we're doing with our derivative flashcards. I've got a bunch of them on the board here. I've got the derivative of x. I've got the derivative of a constant k. I've got the derivative of the product of two functions. I have the derivative of a constant times a function, and I have the derivative of x to the k. Okay, and then this is one we're going to talk about in just a moment, not this one. I want you guys at your seats to fill in all of those. You've got those 5 flashcards there. Write down what's in your gray matter. Not looking at your notes, Write down what's in your gray matter for those 5 flashcards, because certainly they will be on the quest. And you guys in my iPad who are just watching it, okay, you guys should be doing the same thing. Yeah, now I'm teaching people, I'm teaching Grid, my Zoomers, and I'm teaching iPad, my video watchers.
Dr. Warren, what are the last two?
Oh, sorry. This is the derivative of k, a constant, times f of x. And this is the derivative of the function x raised to the k, any constant, x raised to the k.
Thank you.
Oh, thank you, Lorelai. Oh, I'm gonna go start my Zoom, see if I can video this. As you can tell, I never really played football. As you can tell, by those moves right there, that I never played football. I coached football, but I never played football. I was an undefeated football coach. Can you imagine that? Especially with this kind of athletic body right here. Especially the legs. Look how disappointing those are. Okay, look at how disappointing those are. Let's see how we're doing. A lot of this class is flashcards. A lot of this class is being able to remember things so that on a test or a quest, you can immediately pull them out. The derivative of x. Anytime you see the derivative of x in this class, that is what? What is that, guys? What is that? 1. The derivative of a constant. Anytime you are facing the derivative of a constant, what's that? 0. If you have the product of two functions, f times g, what's the derivative of that?
F prime of x times g of x plus f of x times g prime of x.
Perfect. F prime of x times g of x, f prime of x times g of x. Then there's this big plus in the middle, which is unnerving. It's like, wait, it's product and we got a plus. Then f of x times g prime of x. Now it's been a little while and I've never taught in a mask to the camera. Can you guys hear me in the grid? Can you hear me in the grid? Okay, are you guys good hearing me like this? Even in the back? Okay, cool. This is really a version of this that's just a little faster. If the first function's a constant, What's the derivative of k times f of x? What's the derivative of k times f of x? What's the derivative of k times f of x?
A times f prime of x.
Perfect, k times f prime of x. It's like that constant to just be pulled outside of the derivative. Okay, now this is the one we really worked hard on last time. What if you have the derivative of x to the k, where k is any real number? What if you have the derivative of x to the k, where k is any real number? What's the derivative of that?
K times x
K
raised to
times
k.
x to the k minus 1.
K times x to the k minus 1. K times x to the k minus 1. Okay, when I say tangent line, bing, you say what? When I say tangent line, Dr. Warren, it's been a weekend. When I say tangent line, you say what? Bing, write it down. Write it down. When I say tangent line, bing, you say what? Write it down. In my first class today, it was at 8. Two of my people came to class in bed. They just videoed themselves laying on their pillow in bed. And I'm like, do you guys have COVID? Do you guys have COVID? And they're like, no. I'm like, well, okay, I guess that's okay to be in bed with your covers pulled up. But I've never really taught in a hospital before, but that's kind of what I was looking up there. Like, okay, you're in bed and I'm teaching you. But I guess it's better to come to class in bed, right? It's better to be there in bed. Wouldn't it be nice to have beds here, or lazy boys? Wouldn't it be nice to have our lazy boys? Now we get enough room where we could all be lazy, we could all have lazy boys in class. They should be doing something with your student fees, right? I mean, you're not doing anything else with them, you might as well, we should buy us lazy boys. I guess I'm filming this. All right. I say tangent line, you say what?
Y minus
Y minus
equals
f of c equals
x minus c.
f prime of c times x minus c. Now I've got to ask, what is the game of f? What is the game of f prime of c? What does f prime of c do for you in the tangent line?
The slope.
The slope of the tangent line. Okay, the derivative is so much more than that. The derivative is so much more than that. But at least geometrically, it's the slope of the tangent line. Okay, our next flashcard. This is a really important one. What if you have the sum of two functions? What were the words that just came out of my mouth? Yeah, so you guys aren't used to being in class. You guys aren't used to being in the game anymore. It's so easy to zone. It's just so easy to zone. It's so easy to zone in the camera. It's so easy to zone in the camera. Okay, stand up and don't breathe. Stand up and don't breathe. Stand up and don't breathe. We can breathe, just don't breathe partially. Okay. Okay, stand up wherever you're at. Now smack your face. Smack your face. Just don't smack. Say, wake up, 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 wake up. Parker, you're not slapping your face. Parker, sorry. Okay, sit back down, sit back down. Yeah, you'd think I knew all your names, but you look back there, look back there. Your names are printed beside you, so I'm like, hey, Griffin. You know, see, but like, it looks so much better. It sounds better than it is. Griffin, I hope when you're in here, I'll still remember. You wear that Boston hat, I'm with you. Okay, I'll remember. Okay, this is where we're going to start. You guys have in your notes these. If x is approximately 4, you'll remember we use these in product rule. If x is approximately 4, then f of x is approximately f prime of 4 times x minus 4 plus f of 4. So write that down, write it down again. Let's get it into your brains. You might have to prove something like this using it on the quest. So you got f of x is approximately equal to f prime of 4 times x minus 4 plus f of 4. And similarly, g of x is that thing, so write that down. And I'll write g of x is approximately equal for you guys in the grid, g prime of 4 times x minus 4 plus g of 4. Look guys in the room. Isn't it a lot clearer? Isn't it a lot clearer actually being in space? I am so sorry for you guys. What you see, it's just like you're looking through Coke bottles, you know, trying to figure out, what's Dr. Warren writing there? What's Dr. Warren writing there? Okay, now here we go. Here we go. We're on our game. H of x is equal to f of x plus g of x. Here's my function. H of x is equal to f of x plus g of x. Over here, when I'm done, I want to try to figure out what h prime of 4 is equal to. That's my goal. My goal is to show what is h prime of 4 equal to. What's your name right here again?
Miles.
Miles. Miles, what's my goal?
To find what h on x of 4 is.
Find out what h prime of 4 is. Okay, that's my goal. Okay, now you guys are going to start me out with the limit definition. By definition, h prime of 4 is equal to the la 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 la. You write down what's there. By definition, and it's just killing me not to walk amongst my students. I'm so used to just walking around and seeing what you guys got for me. All right, go to grid view, go to grid view. You guys back there, go to grid view, go to grid view, go to grid view, go to grid view. Okay, you guys in here, show somebody else what you've got. Hold up, you guys in the grid, hold up what you've got. You guys show each other what you've got. Show me what you've got. Show some human being what you've got. Okay, just ask the person's name you just cheated off of. Just ask the person's name you just cheated off of.
My name's Hayden. I like your shirt.
Thank you.
Shay, Avalon, Zach. Oh.
Kelly.
Kelly? Kelly. Okay, all right, okay, guys. Okay, the correct answer, what I would want on a quest would be that this is equal to the, you guys help me out, you guys, this would be equal to, who's the Gary Drival-Biss? Who's the Gary Drival-Biss? Who's the Gary? X minus C, and who's in the C location in this game, guys?
4.
4. Now, how about in the numerator? How about in the numerator?
F of x.
And who's the function though? It's not f this time, but it's h. So change that. It's going to be h of x. And then what else would I have up in that numerator? What else would we have in that numerator?
Minus h of 4.
Minus h of 4. Okay. So now, let's see h of x. H of x is equal to, at least you guys don't have to do that anymore. Look at the grid, go back, look at the grid. See how crazy that looks? I mean, do you see Superman, like that? You guys don't have to endure that. If I do this, you're just like, oh, you're way far away, Dr. Warren. But these guys, they don't know what's gonna happen, like that. Punch me back, guys, punch me back. I've had a lot of fun actually trying to, I'm easily amused. How are you doing over there? What's your name?
I'm Jonathan.
Jonathan, good to be back.
Yes, good luck.
Okay, so we're here. Who's h of x? Okay, so find h of 4. I mean, we find this guy. If h of x for any value of x is defined to be f of x plus g of x, I'm going to need this guy. I'm going to need that guy. Who's that guy? H of 4. Write down who h of 4 is. Okay, my back Zach. What do you got h of 4 for me? What's h of 4?
I actually don't know.
Okay, my front Zach. What's h of 4?
Is it 8?
It's not 8. Che.
No clue.
Avalon. James. What do you got for me?
I haven't done it yet.
Okay, Griffin with the Boston hat.
Yeah, I haven't done
Okay, Lorelei. Yeah, do you have anything for h of 4?
Isn't it just f of 4 plus g of 4?
It is, Lorelei. It is just f of 4 plus g of 4.
Thank you.
Thank you, Lorelei. Okay, I mean, guys, this is the way the function h is defined. So like, for example, h of, now you guys know you guys wouldn't do this, but h of beer can. if beer can was a number, h of beer can would be equal to, h of beer can would be equal to,
F of beer can plus E of beer can.
yeah, f of beer can plus g of beer can. Okay, that's what it would be equal to. Okay, so now, let's replace h of 4 with this, and h of x with this. So this would be the same thing as the limit as x approaches 4. Now you guys, keep the Gary Dreibelbis, keep that Gary Dreibelbis down there, he's not changing. But replace h of x with the way it's defined, f of x plus g of x, and put the f of 4 and the g of plus g of 4 in for what Lorelei gave us as h of 4. Okay, sheet, hold up what you have to somebody else, hold up what you have to somebody else. And guys, go to grid view and do the same thing, hold up what you have. As I'm getting you ready for the quest, hold up what you have for somebody else, go to grid view, show everybody else. Hold it up so other people can see it, hold it up nice and okay, if I had $1 for every student that forgot to put parentheses around that, if I had $1 for every time a student forgot to put parentheses, I would not be teaching, I would be just enjoying some Polynesian island right now. Okay, this would be f of 4 plus g of 4 in parentheses, and then my h of x, my f of x plus my g of x. Then my f of x plus my g of x. Okay. Now I'm going up here. Now remember miles. This is what we're after. Remember, that's what we're after. Notice Gary hasn't changed. Notice Gary's still in the same position. I guess I've got this Gary here, my x minus 4. Now this is the move, guys. I've got this minus, but it's minus this plus in parentheses. So it's going to be minus this guy, but it's also going to be minus f of 4, but it's also going to be minus g of 4. I've got to distribute that minus. And so that's all I've done there. That's all. I've got f of x, I've got f of x plus g of x minus f of 4 of g of 4. Okay, how many people can follow so far? How many people are with me so far? How many people are in the game? Like if I said, okay, here's this, how many people can understand that part, limit definition? I mean, you might have messed up the h. You might have messed up, you didn't had it as an f. You might have had c here instead of 4, but I'm believing you understand. After Lorelei said this, did it make sense to you? After Lorelei said that, did it suddenly make sense to you? And then all I've done is substitute it in, and now I'm here. Now this is where the game's going to get a little bit interesting. I can either use this, or I can use limit properties. I can either use this, or I'm going to use limit properties. This is what I use for product rule. What I'm going to use now is limit properties. Are you willing to go with me? Are you willing to surf with me? Are you willing to surf? Some of you aren't shaking your heads. Some of you guys are not even looking. Are you willing to surf? Do this, do this, do this. Do this, do this, do this. Okay, are you guys willing to surf here? Okay, let's get the minus f of 4 with the f of x, and the minus g of 4 with the g of x. Let's get the f's together and the g's together. So that's the next move. So I haven't done much. I've just put f of x minus f of 4, just using a little bit of the associative and commutative properties. I'm getting my f of x with my minus f of 4, and then my g of x with my g minus g of 4. Now, who am I missing? Who am I missing there? Zach, who am I missing? Who have I not written from this line of logic to this line of logic? Who's missing?
Minus 4.
My Gary Dreibel. I've got that guy right there, my x minus 4. Okay, so what's your name here again? Jonathan. Jonathan, so Jonathan, okay. You're gonna help me out, okay? Guys, now guys, this algebra gets confusing. So focus. If you have 2 minus 3 plus 4 minus 7 over 6, you know, Dr. Warren, that's not hard. 2 minus 3 plus 4 minus 7 over 6. Algebraically, is this the same thing as 2 minus 3 over 6 plus 4 minus 7 over 6? Is this the same? Is this the same as this? Is this the same as this?
Yes.
What do you guys think? How many people think yes? How many people think yes? Okay. How do you add fractions? How do you add fractions? Like, for example, if you had 2/3 plus 5/3, how do you add fractions?
The numerator.
As long as the denominators are the same, you add the numerators together and keep the same denominator. Does this make sense? Does this make sense, guys? Is this the way you remember this? Now look here. Is this denominator the same as this denominator? Is this denominator the same as this denominator?
Yes.
So is this fraction the same as adding these two fractions together? Is this fraction the same as adding these two fractions together? Is 2 minus 3 the same as this, and 4 minus 7 the same as that? Okay, guys, that's the algebra I'm using. That's my algebra I'm using. Now focus. Look up here. The 6 is Gary. The 2 is this guy. The 3 is that guy. The 4 is that guy. And the 7 is that guy. The 6 is Gary. 2 is that guy. 3 is that guy. 4 is that guy. And 7 is that guy. So then this limit would be the same as taking the limit. Now you guys are going to help me out. I'm going to have two fractions added together. You guys write the correct numerator and the correct denominator in those two fractions. You write the correct numerator and the correct denominator in those two fractions. I want to break this into two fractions. Oh, it's so nice seeing faces. Miles. Oh yeah. Okay. All right, go to grid view. Guys, hold up what you have, brothers. So that other people see what you have. Go to grid view. Hold up what you have. Hold up what you got so others can see it. Yeah, hold up what you got. Okay. So if I'm looking here, then this numerator would be f of x minus f of 4. And then the denominator would be x minus 4. And over here I would have g of x minus g of 4. And on the bottom I would have Okay, I am not going to make you pull out your limit tools. But if it is the limit of two functions, is the limit of a sum of the limits? Is the limit of a sum of the limits? And so I've got the limit of a sum. I've got a limit of this fraction summed with that fraction. This fraction with that fraction. So this would be the same thing as the limit of this fraction Where's my eraser? I guess I'll go down here, plus the limit of what other fraction? Now you guys help me out. Plus the limit of what other fraction? Plus the limit of what other fraction?
X minus G of 4.
Awesome. G of x minus G of 4 all over x minus 4. Okay, how many people are following? Are you guys following this so far? Are you following the argument? Are you guys following? Okay. Just look at me, and don't look down. What's the definition of f prime of c?
Slope of the tangent line?
That's an application, I love it, that's a geometry. La 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 la. That was a hint. Dr. Warren, what the hell was that? The limit as x approaches c of f of x minus f of c divided by x minus c. This, now you guys, I get geeky chill bumps. I know you guys don't get geeky chill bumps. But if you look here, what do you see? I mean, just look at that. If you look there, if you look at this, what do you guys see there? Look in that location. The limit, some of you in the grid are like, I don't see anything, Dr. Warren, that's so small. The limit as x approaches 4 of f of x minus f of c over x minus c. So this is really, this first limit is really f prime of, this first limit is really f prime of c. But who's the c? Who's the c there? 4. So this is really, that's an equal to f prime of 4. But look here, look at this limit. Look at this limit. Isn't it set up the exact same way, guys? Isn't it set up the exact same way? This would be really G prime of 4. So Miles, what were we trying to find again?
H prime of 4.
H prime of 4. So let's follow the bouncing ball. Okay, or if we're in the Wizard of Oz. Have you guys ever seen the Wizard of Oz? Do you guys know what I'm talking about, the Wizard of Oz? I don't even know with your generation anymore. Like for me, the best TV show, the hottest TV show when I was a kid was MASH. Have you ever heard of MASH, the television show MASH?
Yes.
Okay, just making sure that I'm not like completely out of touch. I'm almost 60 years old and I'm like, I have no idea. Like my daughter said, a word for bad today, well this is an older daughter, older than you, is the word ratchet. Ratchet means bad. And I'm just like, ratchet? Ratchet to me is something I put a bolt on with. So I said, so what's good? What's good? And what's good to you guys? What's the word for good? What's the word for good? I'm trying to see if you're going to come up with the same word she told me. What's the word? You're like, that's good. This is what she said. That's sick. That's sick. And I'm like, what do you mean that's sick? How can sick be good? She goes, like, especially in a pandemic. How can sick be good? She goes, well, that's what you say. That's sick. And I'm like, that's what you say. I don't believe her. Give me a word for good. What does it mean to mean? Like, that's really awesome. What do you say?
Lit.
Lit. Okay, I've never heard that. There's my new word for the year. Lit. My urban vocab. You've just added to my urban vocab. Okay. Guys, this is lit. You're like, no, it's not, Dr. Warren. Yeah, this is lit. I mean, we wanted to find H prime of 4, right? Follow the yellow brick road. Follow the yellow brick road. Da 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 da. Stop singing. Da 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 da. How many people understand all the steps that we're using to get here? And then ultimately, we reached f prime of 4 plus g prime of 4. So the question was, what's h prime of 4? What is h prime of 4? It's f prime of 4. It's f prime of 4 plus. It's f prime of 4 plus g prime of 4. It's f prime of 4 plus g prime of 4. Now don't get mad. Don't get mad. What if I said, oh crap, I screwed up. I screwed up, guys. Sorry. I really want h prime of 7. I really want h prime of 7. You'd be like, Dr. Warren, we're not following the yellow brick road again. We're not doing the yellow brick road. How many people think they could guess what the answer would be? How many people could guess what the answer would be at the end? What would it be? What would it be, guys? F prime of 7 plus g prime of 7. This is what I want to see today, and I'm not seeing it. What if it was h prime of sun? What if it was h prime of sun? What would it be? What if it was h prime of sun, where sun was a real number? What would it be? What would it be? Okay. Now suppose it was f prime. Suppose it was h prime of, what's your name right here?
Steven.
Stephen, give me any symbol, Stephen, anything you want.
Banana.
Banana, I like that. What if it was h prime of banana? What if it was h prime of banana? F prime of banana plus g prime of banana. Now here's the hard one. What if instead of banana, I just made it x? What if instead of banana, I just made it x? What if I just made it x? H prime of x would be equal to, H prime of x would be equal to F prime of x plus g prime of x. And that's the flashcard, guys. That's the flashcard. That's the flashcard. Write this down. The derivative of a sum. Write it down. The derivative of a sum. If you're trying to take the derivative of a sum, this is f of x plus g of x for you guys who are in the grid. This is f of x plus g of x prime is the sum of the derivatives. Write that down. Is the sum of the derivative. And don't write the word sum and derivatives. Write down f prime of x plus g prime of x, because that's what we showed. Okay, what time is it? What time is it?
12:34.
12:34. What time does class end? What time is class? 12:50. I think you guys need to stand. I think you need to stand. Stand. Stretch without breathing too much. This classroom's not going to be the classroom that brings JMU down. We're not bringing JMU down. Okay, sit back down. But I don't know, like, does anybody else, you guys might be too young to have, does anybody live on Mason Street? Is there anybody that lives on Mason Street here? Okay, so I was walking down Mason Street last night, and there's a bunch of houses with students in it, and I was looking at like what was going on Mason Street, and I'm like, okay, I don't think going to class has been the problem. I don't think going to class has been the issue. I don't think that's been the problem. Yeah, no. It was like watching a party. I was like really jealous. I'm like, can I go up there? I'm asking my wife, can I go up to the porch? I want to go on that porch. It looks like they're having a lot of fun up there. Playing beer pong. Okay. I'm just giving you quiet time. I'm giving you quiet time so you don't have to hear my voice. Take out your phones. See who's texted you. Go ahead, take them out. Take out your phones. I don't normally let you do this, but if you got a phone, take it out. You can see who's texted you. Okay, now, text your mom. Get ready. Text your mom. Okay, say, love you, mom. my math teacher's making me do this. Say, love you, Mom, my math teacher's making me do this. And then send that text, See, I have 5 daughters. Do you know how many times I get love you, Dad? Do you know how many times I get like a random love you, Dad? Do you know how many times? That many times. It's never love you. I always hear from them like, I need money. That's what I hear. Other than that, then I need money. Or like they'll drive my car, okay? Which I pay insurance for, which I put gasoline into, okay? And they'll call it their car. This is my car. Until the car breaks down. Then they'll call it the car instead of their car. It's no longer their car, it's the car. The car broke down. Okay, I'm just bringing this up, okay? So if you get back concern from your mother, if you get back like, are you okay? You should probably tell your mom you love her a little bit more often. If you get back concern, are you okay? You should be probably telling your mom you love each other. You love her a little more often. Okay, enough of that. Miles, I don't know what your mom's gonna say. If she texts you back, I need to know.
Okay, I'll let you know.
All right. Okay. We are now free. What do you mean, Dr. Warren? Can we quit? No. We are now free almost from the limit definition of derivative. When I say the definition f prime of c, you say, come on, we just did this. It's like sand, you can't hold on to it. When I say the definition f prime of c, you say the limit as x approaches c of f of x minus f of c all over Gary x minus c. You on this quest coming up on Friday are going to have to use that limit definition. But we've now developed enough flashcards. These 6 flashcards are enough where we can start taking the derivative without the limit definition pretty easily. Like, let's take a function. Give me a function. Any function you want. Any function. There's 20 of you. I'm getting nothing. It's like
X plus 4, x squared plus 4x.
x squared plus 4x plus 7. Okay. If I said find f prime of 2, up until now, you're going to have to use the limit definition. I mean, how many people are pretty comfortable they could actually, if I said use the limit definition, how many people think they could probably do that? Factor, cancel out, slash, and find that. But if I did this, x to the 12th plus x to the 10th, how many people have less confidence now? How many people have less confidence? Okay, the people that know have less confidence. Other people are like, It's kind of like those nature documentaries. Have you ever seen those? Like they have the Crocodile Creek, and they have this herd of antelopes, and you see the antelope. You always know that first antelope running across the creek is going to be just fine. You just know it. You know they're just going to be just fine. It's always that last little one that's kind of looking at the clouds, far, far behind all the rest of them. You just know nothing good is going to happen when that little antelope crosses the Crocodile Creek. You just know that, okay? And that's what I feel about my students often. Like most of them, like when I look at the classroom, there's always the one that's with me, like in the game, almost a little too excited. You're just like, okay, no, that's good. But they want to answer every question. I don't have anybody in here like that, which is different. Yeah, okay.
Are you kidding? I'm sitting next to you.
Well, Paris a little bit. Okay, but there's always the one that looks like they've just come to class and are just completely high the entire time. They're sitting in the back, they don't take notes, they just stare off into space, and that's that little antelope. You're just like, oh, you little antelope. Well, I wish I could take care of you. Come here, little antelope. which is what I'm doing right now. I'm waking up my damn antelopes. Now, back to here. Dr. Warren, is there a faster way I could do this? And the answer is yes. The answer is yes. If I want to find the derivative of this now, using my flashcards, I can say, well, f prime of x would be the derivative, would be like the same thing as taking the derivative of that. Would be like the same thing as taking the derivative of this. Now look at the flashcard we just created. Look at the flashcard we just created. The derivative of f plus g is equal to. The derivative of f plus g is equal to the f prime of x times g of x. So this would be equal to the derivative of this function plus the derivative of this function plus the derivative of that function by using my flashcard.
I have a question. The derivative of f of x plus g of x over there, is that equal to h prime of x?
That is equal to h prime of x. Yeah, that's, because if I think about it this way, if you allow me, sorry, Miles asked a great question. Miles is over here, you guys can't see him. I don't want to turn the camera because then I'll never get it positioned so you guys will see the board right. He goes, Dr. Warren, you had this h prime of x, and I agree you showed that, but where's this coming from? Well, imagine, Miles, I did this. This h prime of x is kind of like saying h of x prime. But who is h of x? Go back and look at your notes. Who was h of x?
f of x plus g of x.
So this is the same thing as f of x plus g of x prime, and that's what I put there. That's what. But great question. Great question. Okay, how many people are with me to here? How many people are with me to here as far as where we're there? Okay, now, how many people could take that derivative? How many people could take that derivative? How many people like, I own that, Dr. Warren, derivative of 7. What's the derivative of 7? What's the derivative of 7? What's the derivative of 7? 0. Now, let's look at this derivative. The derivative of x to the 12th. The derivative of x to the 12th is 12x to the 11th. It's like, remember, you're just using this flashcard, you bring the 12 down as a coefficient, and you subtract 1. Sorry, I'm dropping my mask. Taking a deep breath. It's just like teaching. I mean, it's also surreal. I see my students in masks. That doesn't look normal. I see an iPad in my room, not normal. I see you guys on the grid, not normal. I see you guys in my class, only half of you, not normal. And it's still working, kind of. Are you guys following? Is this working? As insane as it is, Henry, is this good for you? Are you making it? Okay. All right. This flashcard is this one, right here. A constant times a function's derivative is the constant times the derivative of the function. So this would be like 4 times the derivative of x to the 10. But what's the derivative of x to the 10? What's the derivative of x to the 10?
10x to the 9.
10x to the 9. So this would be 12x to the 11 plus 4 times 10 x to the 9 plus 0. Or cleaning it up, 12x to the 11 plus 40x to the 9. But guys, if we don't have to use the limit definition of derivative, couldn't we almost do that from the very beginning? I mean, if you're just looking at this function, couldn't you almost do that from the very beginning? What's the derivative of x to the 12? What's the derivative of x to the 12? 12x to the 11. What's the derivative of 4 times x to the 10?
40x to the 9.
And what's the derivative of 7? We're not even applying any of my flashcards. How many people realize they can do this? How many people realize as long as I don't ask for justifications, as long as it's not approved, and we just use the flashcards all at once, are you game for that? Are you game for that? So let's see how game you are. Here's my function. G of x is equal to x to the 7th minus 4x to the 5th plus 3x cubed plus 7x squared plus 8. What's g prime of x equal to? What's g prime of x equal to? Find it. There's your function, and I'll read it off again for you guys in the grid. G of x is equal to x to the 7th minus 4 times x to the 5th plus 3 times x cubed plus 7x squared plus 8. Find the derivative. Okay, guys, go to grid view. Okay, hold up what you got, guys. Show somebody else what you've got. See what you've got. Show somebody else what you've got there. Okay, help me out. Help Dr. Warren out. What did you guys get? What'd you get for the derivative of x to the 7th? What'd you get for the derivative of x to the 7th?
7x.
How about the term 4x to the 5th? The minus 4x to the 5th. What'd you guys get with that? 4 times 5 is 20. X to the 4. How about the 3x cubed? What'd you guys get? The 3x cubed, what'd you guys get? And how about the x squared? 14x. And then how about the 8? Zero. Did anybody get that? Did anybody get that? Did anybody get that in here? Okay. Now I've got to ask, so what would g prime of 1 be? I mean, if this is g prime for all values of x, Miles, what did I just say?
If that is g prime value for all of x.
Perfect. If this is g prime of x for all values of x, what would g prime of 1 be equal to? Write down what you think it would be. What would g prime of 1 be? Anyone? Does anybody have an answer? For me?
Is it 10?
Wherever I'd see an x, I'd put a 1. So we'd have 7 1 to the 6, which is 1, minus 20 times 1, plus 9, plus 14. Now Miles asked, is it 10? I don't know. I'm going to figure it out myself. Okay, I'd go 7 plus that is 21, minus 20. Miles, it is 10. There it is. No, we're not going to do it. But with a calculator, could you find g prime of 2? If I gave you a calculator, could you find g prime of 2? Okay, but without a calculator, no way. There's not going to be any calculators on the Quest. On Quest 2, there's no calculators. It's just your brain. It's a brain and pencil. I will pick numbers. It's an advantage, not a disadvantage. I'll pick numbers that make it easier, so you don't even need a calculator. Okay. Look at something that tells time. 12:51. Okay, so I've gone over. I apologize. As you leave today, I say tangent line. You say. Okay, good. Just keep going. You guys can leave. Thank you for joining me in this brand new world where I've got live students and virtual students. Thank you guys.
Thank you, Dr. Warren.
Thank you guys. Thank you for coming. Thank you for risking your life to come out and help me. What's your name here? Lainey, thanks. Kelly.